এই প্রথমে একটু খাবো, আপনি আগে সেট করে চিন্তা করেন মানে চিকেন।
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती।
Hello, check, check. Hello. Hello, check, check. Hello, check. Mic testing. Hello. Hello, check, check, check. Hello. 1, 2, 3. Hello, check, check. Hello, check, check. Hello. Hello. Hello, check, check. Hello. Hello, check, check. Hello, check, check. Mic testing. Hello. Hello, hello. Hello, check, check. Hello.
নমস্কার। আমাদের চিফ গেস্ট চলে এলেই আমরা আমাদের প্রোগ্রাম শুরু করে দেব, ততক্ষণ একটু ধৈর্য ধরে বসুন আপনারা প্লিজ। ভগবান, তুমি যুগে যুগে দূত পাঠায়েছ বারে বারে দয়াহীন সংসারে। তারা বলে গেল ক্ষমা করো সবে, বলে গেল ভালোবাসো, অন্তর হতে বিদ্বেষ বিষ নাশো। বরণীয় তারা, স্মরণীয় তারা, তবুও বাহির দ্বারে আজ দুর্দিনে ফিরানু তাঁদের ব্যর্থ নমস্কার। আমি যে দেখেছি গোপন হিংসা কপট রাত্রি ছায়ে হেনেছে নিঃসহায়ে। আমি যে দেখেছি প্রতিকারহীন শক্তের অপরাধে বিচারের বাণী নীরবে নিভৃতে কাঁদে। আমি যে দেখিনু তরুণ বালক উন্মাদ হয়ে ছুটে কি যন্ত্রণায় মরেছে পাথরে নিষ্ফল মাথা কুটে। কণ্ঠ আমার রুদ্ধ আজিকে বাঁশি সঙ্গীত হারা। আমাবস্যার কারা লুপ্ত করেছে আমার ভুবন দুঃস্বপনের তলে। তাই তো তোমায় শুধাই অশ্রু জলে, যাহারা তোমার বিষাইছে বায়ু নিভাইছে তব আলো। তুমি কি তাদের ক্ষমা করিয়াছ? তুমি কি বেসেছ ভালো? নমস্কার। মন কারোর ভালো নেই, আমাদের মন ভালো নেই, শহরের মন ভালো নেই, তবু কাজ আমাদের করতে হচ্ছে। কর্মই আমাদের জীবন, তাই কাজ করে যাচ্ছি। এবং যে জিনিস আমাদের অন্তরকে জাগিয়ে রাখে সেটা হচ্ছে সঙ্গীত। তাই সেই সঙ্গীতকে আজকে একটু আমরা নিজেদের অন্তঃকরণে নেব, যাতে আমরা জেগে থাকতে পারি। সেই জন্য আমাদের মাঝে আমরা ভীষণ গর্বিত বোধ করছি যে যিনি আজকে আমাদের মুখ্য অতিথি হিসেবে এসেছেন তিনি আর কেউ নন, পণ্ডিত সমর সাহা। সমর সাহা ওনার আলাদা করে কোনো পরিচিতি দেওয়ার আমার দরকার নেই, তবু আমি দেব। তার আগে আমি ডেকে নেব আমাদের মুখ্য অতিথি পণ্ডিত সমর সাহা, আমাদের ডিরেক্টর ডক্টর নরেশ চন্দ্র মুর্মু, আমাদের সিনিয়র মোস্ট সায়েন্টিস্ট ডক্টর শীতেন্দু মণ্ডল, আর আমাদের কন্ট্রোলার অফ অ্যাডমিনিস্ট্রেশন সিদ্ধার্থ দেকে প্রদীপ জ্বালাবার জন্য, প্রদীপ প্রজ্বলন করে আমরা আমাদের অনুষ্ঠানকে শুরু করব। প্লিজ আপনারা সবাই একটু চলে আসুন। আমাদের ভারতীয় সংস্কৃতির ধারক বাহক এই অগ্নিকে সাক্ষী রেখেই আমরা সবকিছু করি।
তুষার হার নবনা या शुभ्रवस्त्रामृता या वीणाभरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर सरस्वती भगवती निशेष जाड्या
থ্যাংক ইউ। আমি একটু স্টেজে থাকতে বলবো আপনাদের সবাইকেই। স্টেজেই থাকুন প্লিজ, কারণ আমরা চিফ গেস্টকে একটুখানি বরণ করে নেব। প্রথমে একটা ফ্লাওয়ার বুকে দিয়ে আমাদের অ্যাডমিনিস্ট্রেটিভ অফিস কন্ট্রোলার অফ অ্যাডমিনিস্ট্রেশনকে বলবো ফ্লাওয়ার বুকে দিয়ে ওনাকে বরণ করে নিতে। প্রথমে স্যার ওয়েলকাম, আপনাকে স্বাগত। আমরা ধন্য যে আপনি আমাদের চিফ গেস্ট হয়ে এখানে এসেছেন। এবার আমাদের ডাইরেক্টর সাহেব ওনাকে উত্তরীয় দিয়ে বরণ করে নেবেন। আর CGCRI এর তরফ থেকে একটা ছোট্ট মেমেন্টো, টোকেন অফ লাভ। থ্যাংক ইউ। পণ্ডিত সমর সাহার একটুখানি আমি পরিচয় আপনাদের কাছে দিয়ে রাখি। Some are born layadar or with a sense of rhythm, and some learn to be layadar, skillful player. 1956 born, Shamar Shaha is gifted with both. His formal training started under Sri Sachidanand Goswami in the year 1964 and then flowered under the able guidance of Sri Krishna Kumar Ganguly, Natu Babu of Banaras Gharana since 1969. 1976 onward, his smiling lady luck reached him to the world of stars to provide tabla accompanied a number of legends such as Padma Bhushan Girija Devi, Padma Bhushan Pandit V.G. Jog, Ustad Sharafat Hussain Khan, Ustad Latafat Hussain Khan, Sangeetacharya Bhishmadev Chattopadhyay, Ustad Mustaq Ali Khan, and many others. He joined 1978 ITC Sangeet Research Academy as its faculty member and accompanied tabla with Pandit Bhimsen Joshi, Pandit Jasraj, Pandit Mallikarjun Marsoor, Bidushi Shobha Guttu, Ustad Ali Akbar Khan, Ustad Vilayat Khan, and many other maestros. Won gold medal in Sangeet Praveen from Bangiya Parishad. The Government of India invited to participate in the India Festival in USA. Pandit V.G. Jog Award 2023, Botuk Nandi Award, established Sangeet Piyasi in the year 1991 with an aim to promote and propagate Indian classical music through music conferences, unearth talented young musicians, and give scholarship and stage for their debut, and to organize social activities like helping financially challenged musicians in all possible manner. এই হেন ব্যক্তিত্ব আজ আমাদের মাঝে আছে, আমরা গর্বিত। আমি প্রথমে একটু ডেকে নেব আমাদের ডিরেক্টর ডক্টর নরেশ চন্দ্র মুর্মুকে দুটো শব্দের জন্য, এবং তারপর আমাদের চিফ গেস্টকে আমি ডাকবো ওনার এনলাইটনিং দু চার শব্দের জন্য। ডক্টর নরেশ চন্দ্র মুর্মু, ডাইরেক্টর CGCRI, স্যার।
Good afternoon once again to everyone present, and distinguished artists is there today to perform these these occasions, and it's a great culture heritage that we want to just discussing a few minutes before that. They're a little bit unheard that such kind of programs will be taken place in the CGCRI. But traditionally CGCRI, or even for the CSR labs as such, we host very classical kind of programs, generally in Foundation Day or any of these such programs. So it's not the first time that we are doing, it's a generally traditions that we do it. And with that, we welcome you on these occasions, and I hope you will enjoy this program. Thank you.
থ্যাংক ইউ স্যার। আমি এবার আগ্রহ করব, ডেকে নেব পণ্ডিত সমর সাহাকে আগামী প্রজন্ম এবং মিউজিক লাভারদের জন্য দু চারটে শব্দের জন্য। পণ্ডিতজি।
উপস্থিত সকলকে আমি প্রণাম জানাচ্ছি। প্রথমেই আমাদের দেশ যেভাবে চলছে আমরা সকলেই, এর আগে উনি বলছিলেন, তো আমি প্রথমেই বলবো মৌমিতা দেবনাথ, তার জন্য আমরা অন্তত যে যার সিটে বসে তার আত্মা শান্তি কামনা করব 1 মিনিট। যে যার সিটে বসে, কারণ সিট থেকে উঠলে ধপ করে একটা আওয়াজ হবে, আমরা একদম সাউন্ডলেস আমরা তাকে প্রণাম জানাতে চাই। ধন্যবাদ। আমার নামে অনেক কিছুই বলা হলো, আসলে আমি তা না। এখন নেট জগতে অনেক কিছু লোকে খুঁজে পেয়ে যায়, কোথা থেকে পায় আমিও জানি না। আমি হিরণময়কে বলছিলাম যেগুলো তো আমিও জানি না আমি যেগুলো পেয়েছি। তো যাই হোক, আজকে আমার খুব ভালো লাগছে। পুরোনো দিন থেকে শুনে আসছে গুরুদের কাছে, কর্ম করো ফল পাবে। আজ দেখছি কোনো কর্ম নেই, অনেক কিছু আমি পেলাম। সেই জন্য এই ইনস্টিটিউশনকে আমি অনেক 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 ধন্যবাদ জানাই। আমি আজকে এখানে প্রথম এসেছি। এখানে অনেকেই কাজ করেছেন যারা আমার পরিচিত, কিন্তু কোনোদিন আসা হয়নি। আরো আমার ভালো লাগছে যে মিউজিকটা নিয়ে আমরা কাজ করি, যে মিউজিকটা সারা পৃথিবীতে ভারত ছড়িয়ে দিয়েছে, ভারতবর্ষের এই যে দর্শন আর মিউজিক, এটা কিন্তু আমেরিকায় যান, জাপান যান, যেখানেই যান না কেন, আমরা আমাদের পূর্বপুরুষরা এই মিউজিক দিয়ে এসছে। আজকে যদি এত অশান্তি আমাদের দেশে হতো না, যদি সবার মধ্যে একটু মিউজিকের ছায়া থাকতো। এই মিউজিকটা শান্তির প্রতীক। সুতরাং আজকে যেভাবে যে কোনো জায়গায় 2 কিলোমিটার যেতে গেলে 1 ঘন্টা সময় লেগে যাচ্ছে, আপনারা হয়তো অনেকে এইভাবেই পেরিয়ে এখানে এসেছেন। আমার ধারণা যদি সকলেই একটু একটু মিউজিক করেন, 10 ঘন্টা প্র্যাকটিস করতে হবে তা না, মিউজিকের সাথে ইনভলভমেন্ট যদি থাকেন, তাহলে আমার মনে হয় আমরা নিজেরাও শান্তি পেতাম, আমরা দেশকেও শান্তি দিতে পারতাম। তো সেইটা আজকে এখানে আমরা এসেছি একটা মিউজিকের অনুষ্ঠান, সেটা আরো ভালো লাগছে। যে যিনি প্রথমে বাজাবেন তিনি একটা দায়িত্বপূর্ণ জায়গায় চাকরি করেন, সেখান থেকেও মিউজিক করেন এই কারণেই যে দায়িত্বটা যেন বজায় রাখতে পারেন, মিউজিকটা করলে সেটা বজায় থাকবে। আপনারা দেখবেন আসবে একটু পরে। তারপরে আমারই 2 জন ছাত্র যারা এখানে তবলা সোলো বাজাবে, তারাও দায়িত্ব পালন করে ঘর সংসার সামলে তারপরে এত বড় একটা দায়িত্ব নিয়ে, কাজের দায়িত্ব নিয়ে করার পরেও যে মিউজিকটা করে, তারা তাদের নিজেদের আনন্দের জন্য করে, ভালোবাসার জন্য করে। সেই জন্যই তারা তাদের কাজের দক্ষতা দেখাতে পারে, সাথে মিউজিকটা আছে বলে। আমিও এইটাই করি, কিন্তু আমার এটা প্রফেশন, আমাকে একটু ঘুরে বেড়াতে হয় এদিক ওদিক। সকলের কাছে শুভকামনা চাইছি যে আমাদের মিউজিক যেন যেভাবে এগিয়ে গেছে ধীরে ধীরে আরো এগিয়ে যাক। আমাদের মিউজিক থেরাপিও আছে, আমরা সকলেই জানি, কিন্তু কোথাও মিউজিক বললেই যেন অনেক মানুষ জিজ্ঞেস করেন, আচ্ছা মিউজিক তো করেন কিন্তু করেনটা কি? আমি এরকম অনেক জায়গায় ফেস করেছি। আমি বললাম যে আমি তো তবলা বাজাই, না সে তো বুঝলাম, কিন্তু আপনি করেন কি? আমি যদি বলতাম যে আমি সাউথ সিটির সিকিউরিটির গার্ডের কাজ করি, তাহলে উনি বা হ্যাঁ একটা দারুণ চাকরি করেন। কিন্তু আমি যে মিউজিক করি, আমি যে একটু দেশ বিদেশ ঘুরে বেড়াই, ভাবছে এ খায় কি করে মিউজিক করে। কিন্তু মিউজিক যদি করে, সবাই রবিশঙ্করজি হবে না, সবাই কিষাণ মহারাজজি হবে না, সবাই বিলায়ত কা হবেন না, কিন্তু মিউজিক যদি কেউ করে ডাল ভাতেরও অভাব হবে না, এটা একদম 100% গ্যারেন্টি। কিন্তু আমাদের এইটা শুনে আসছি, আমি একটা গল্প বলে আমি শেষ করব। আমরা যাচ্ছিলাম আসানসোলে একটা ট্রেনে, তো এক ভদ্রলোক বললেন, দাদা কোথায় যাচ্ছেন? বললাম আসানসোল। আপনি কোথায়? না আমি দুর্গাপুর যাচ্ছি, উনি আসানসোল। ও আচ্ছা, আপনি করেন কি? আমি বললাম আমি তবলা বাজাই। না সে তো বুঝলাম, কিন্তু কি জব করেন? আমি বললাম এটাই আমার জব। না আপনি আমার কথা বুঝছেন না, তবলা তো অনেকেই বাজায়, আপনি করেনটা কি? চাকরি কি করেন? বলে আমার কোনো চাকরি নেই, আমি এইটাই করি। তখন বলছে আপনি কি প্লেনে ঘুরে বেড়ান? বললাম কেন বলেন তো? বললো আপনার একটা বাক্স দেখছি, ওখানে ওর কালারটা বোঝা যাচ্ছে না, অনেক ফ্লাইটে স্টিকারে ভর্তি। তো আমি বললাম হ্যাঁ আমি একটু প্লেনে ঘুরে বেড়াই। তখন বললো না তবু কি করতে যান, কি করেন? তা বলে এই তবলা নিয়েই যাই। ইনি তো আশ্চর্য হয়ে গেছেন, আর আমিও খুব জোর রেগে গেছি ওনার উপরে। মানে এতক্ষণ বলতে বলতে বর্ধমান পৌঁছে গেছি, ওনাকে কচুরি বর্ধমানে পাওয়া যায় সেটা খাইয়েছি যাতে চুপ করেন, কিন্তু দেখলাম উনি চুপ করলেন না। তারপরেও বলছেন করেনটা কি? আমি বললাম শুনুন আপনি কি করেন? বলছে আমি একটা ব্যবসা করি। এমনি কোথায় যাচ্ছেন? বলে আসানসোলে। আপনার ওই বাক্সটা কি আছে? বলে আমার ব্যবসার জিনিস আছে, একটা ছোট ট্রাঙ্ক মতো। আমি বললাম আপনি আপনার ব্যবসাটা ছেড়ে আমার তবলার লাইনে চলে আসুন, আপনারও বাক্সতে প্লেনের স্টিকারে ভর্তি হয়ে যাবে। তো সেই জন্য মিউজিকটা আমাদের কাছে খুব আনন্দের, আমরা আনন্দ পাই। আমরা এই মিউজিকের জন্য সারা দেশ বিদেশ ঘুরে বেড়াই, 5টা মানুষের ভালোবাসা পাই। সেই ভালোবাসার থেকে আজকে আমি এখানে আমন্ত্রণ পেয়েছি। সকলকে নমস্কার।
সঙ্গীত আসলে আমাদের মনের কোমল ভাবনাগুলোকে জাগ্রত করে। সেই জন্য এখন আমাদের সামনে যে আমি অনুষ্ঠান সোজা নিয়ে চলে আসছি, আমাদের এখন অনুষ্ঠান বাঁশুরি বাদন। আর যিনি বাঁশি বাজাবেন তিনি শ্রী ইন্দ্রজিৎ বাসু, উনি আইপিএস অফিসার। আমরা জানি যে আইপিএস হওয়া কত কঠিন এবং তার কর্মক্ষেত্রেও প্রচণ্ড কঠিন, কিন্তু তার মধ্যে উনি বাঁশি বাজান। তো সেই কোমল ভাবনাকে নিজের জাগ্রত রাখার জন্য উনি এগুলো করেন। ওনার বিষয়ে আমি একটু বলে দিই। হেলিং ফ্রম কলকাতা, Sri Basu started learning Bansuri systematically during his college years. Later, he pursued his passion under the discipleship of late Pandit Nikhilesh Roy, a former professor of Rabindra Bharati University, Department of Music. Indrajit Basu has been performing in numerous programs of classical music. He has performed in almost all major music ceremonies or conferences such as Dover Lane Annual Music Conference, Rajya Sangeet Academy Annual Music Conference, Uttarpara Sangeet Chakra Annual Conference, Sangeet Piyasi Annual Conference, Baba Alauddin Khan Sangeet Samaro, Ramakrishna Mission, Golpark, Belur Math, etc. His soulful presentation of melodious ragas on Bansuri have become a part of the culturescape of Kolkata. Besides being a serious student of Hindustani classical music, he is a serving IPS officer of West Bengal cadre, Shri Indrajit Basu, এবং তার সঙ্গে সঙ্গত করবেন তবলাতে শ্রী বিভাস সাংঘাই। আমি দুজনকেই একটু ডেকে নেব স্টেজেতে। Shri Bibhas Sanghai had initiated learning tabla from his father, Professor late Lalit Mohan Sanghai, at his very earlier age. Later on, received his talim from the legend tabla player of Banaras Gharana, Pandit Nanku Maharaj and Pandit Krishna Kumar Ganguly, that is Natu Babu. He is also a senior disciple of tabla maestro Pandit Shamor Shaha. A gold medalist in percussion music from Rabindra Bharati University. আমি দুজনকেই ডেকে নেব এবং ডেকে নেব আমাদের সিনিয়র মোস্ট সায়েন্টিস্ট শ্রী শীতেন্দু মণ্ডলকে। স্যার আপনি আসুন, ওনাদেরকে আমরা বরণ করে নেব একটু। শ্রী ইন্দ্রজিৎ বাসু, শ্রী বিভাস সাংঘাই। ডেকে নেব আমাদের ডিরেক্টর স্যারকে। স্যার ওনাদের উত্তরীয় দিয়ে আমরা বরণ করে নেব। A small token of love from CGCRI. থ্যাংক ইউ স্যার। এবার আমরা প্রোগ্রামে চলে যাব।
নমস্কার, শুভ অপরাহ্ন। এখানে বয়োজ্যেষ্ঠরা রয়েছেন, সম্মানীয় ব্যক্তিরা রয়েছেন, ইনস্টিটিউটের অর্গানাইজেশনের ডাইরেক্টরস সকলকে এবং যারা শ্রোতৃমণ্ডলী সকলকে আমার বিনম্র নমস্কার জানাই। I am more than overwhelmed to be performing here. এরকম জায়গায় এত সুন্দর মানুষজন, তো কখনো ভাবিনি এখানে এরকম সুযোগ পাবো। তো যারা উদ্যোক্তা আছেন তাদেরকে ধন্যবাদ জানাবো, সুকুমলদাকে ধন্যবাদ জানাবো। আর আজকের দিন একটা কোয়েনসাইড করে যাচ্ছে একটা পুণ্যতিথির সাথে, জন্মাষ্টমী, ভীষণ আনন্দের একটা মুহূর্ত। তো একটা গীতায় একটি শ্লোক একটু বলার অনুমতি চাইছি। মূকম করোতি বাচালম পঙ্গুম লঙ্ঘয়তে গিরিম যৎ কৃপা তমহম বন্দে পরমানন্দ মাধবম। তো আমরা সকলে এক শক্তির দ্বারা পরিচালিত, তার কাছে যখন সারেন্ডার করি তখন ভালো কিছু হয় এরকম আশা থাকে। তো আজকে আবার সেই প্রার্থনা জানাবো আজকের অনুষ্ঠান যেন আপনাদের ভালো লাগে। যেহেতু জন্মাষ্টমী, তো ভেবেছিলাম একটু মানে এটা তো সায়েন্সের জায়গা, সায়েন্টিফিক এক্সপেরিমেন্টসের, তো একটু ছোট এক্সপেরিমেন্ট বলবো না, চিন্তা। রাধা কৃষ্ণের বিভিন্ন রকম ভাবের কথা লেখা আছে শাস্ত্রে। তো একটা তো বিরহ মিলন, বিরহ অর্থাৎ ব্যবধানের কথা, আর একটা হচ্ছে মিলন। তো দুরকম ভাব, তার জন্য দুটি রাগ অবশ্যই অল্প পরিসরের মধ্যে পেশ করব। তো প্রথমে বিরহ, তারপরে মিলন। বিরহের কথা হলো, তারপরে মিলনাত্মক, জানাচ্ছি আমাদের মধ্যে পণ্ডিত সমস্যা মহাশয় উপস্থিত রয়েছেন, ওনাকে প্রণাম জানাচ্ছি। আর বাকি সকল গুরুজনকে সকলকে নমস্কার জানিয়ে অনুষ্ঠান এখানে শেষ করলাম।
সাধু। বিরহের পর মিলন সবসময় সুখের। আর ধন্যবাদ জানাবো ইন্দ্রজিৎ বাবু এবং বিভাস বাবুকে আমাদের এই সুখের সাগরে বইয়ে নিয়ে যাওয়ার জন্য। আজ জন্মাষ্টমী, আর এটা কোইন্সিডেন্সই যে জন্মাষ্টমীর দিন আমরা যে প্রোগ্রাম করেছি তাতে বাঁশুরি বাদন ছিল। শুনেছি শ্রীকৃষ্ণ যখন বাঁশি বাজাতেন, শ্রীকৃষ্ণের বাঁশির এমন অমোঘ টান ছিল যে শ্রী রাধিকা কখনো সেটা ইগনোর করতে পারতেন না। কেমন ছিল সে বাঁশি সে তো আমাদের জানার উপায় নেই, তবে এই বাঁশি শুনে সবাই স্পেল বাউন্ডেড, মন্ত্রমুগ্ধের মতো বসেছিল। আমার আন্তরিক শ্রদ্ধা ও প্রণাম দুজনকেই। থ্যাংক ইউ। চলে যাব আমাদের নেক্সট প্রোগ্রাম, ডুয়েট তাবলা। ডুয়েট তাবলায় আছেন আমাদের নিজেদের লোক। আমরা অনেক সময় জানতেই পারি না যে কার মধ্যে কি আছে। আমরা শুধু অফিস আসি, কাজ করি, বাড়ি চলে যাই। কিন্তু আমাদের অনেকের মধ্যে অনেক ধরনের প্রতিভা আছে। সেই রকমই একজন প্রতিভাধর সায়েন্টিস্ট আমাদের সোমনাথ দা। আজকের এই প্রোগ্রামেতে ডুয়েট তবলাতে থাকবেন সোমনাথ বন্দ্যোপাধ্যায় এবং সুকোমল মণ্ডল, এবং তাদের সঙ্গে হারমোনিয়ামে থাকবেন পণ্ডিত হিরণময় মিত্র। আমি হিরণময় মিত্রের একটু পরিচয় জানিয়ে দিতে চাই। হিরণময় মিত্র started learning tabla, vocal music and harmonium from his childhood. His training in tabla began under Pandit Sanjay Mukherjee, learned vocal classical from Sri Arun Chatterjee and Pandit A. Kanan. He is also a very good light music performer. He learned light songs from Sangeetacharya, late Siddheshwar Mukhopadhyay and late Sri Sukumar Mitra. Sri Mitra is a graded artist of All India Radio in tabla, vocal and harmonium. Hiranmay Mitra, a BA Honours in Vocal Classical Music from Rabindra Bharati University, has achieved the opportunity to accompany with many of the graded artists. Similarly, worked with many dancers also, such as Ashim Bondhu, Nandini Sinha, Sumitra Mitra, Sushmita Banerjee, Jayanti Mukherjee, Jayashree Acharya and Padatik group. He has participated not only at Kolkata but also at national and international conferences. He has participated in multicultural festival in Australia in the year of 2004. সেই হিরণময় দাও আমাদের মাঝে আজকে আছেন। আমরা চলে যাব আমাদের নেক্সট প্রোগ্রাম, ডুয়েট তাবলা। হারমোনিয়ামে সঙ্গত করবেন পণ্ডিত হিরণময় মিত্র, তবলায় থাকবেন শ্রী সোমনাথ বন্দ্যোপাধ্যায় এবং শ্রী সুকোমল মণ্ডল। একটু সময় লাগবে, যন্ত্র যতক্ষণ ব্যবস্থাপনা হয় ততক্ষণ, তারপরে ওনারা প্রস্তুত করবেন। আমি ডেকে নেব আমাদের কোফা স্যারকে একটুখানি আর্টিস্টদের ওয়েলকাম করার জন্য। স্যার প্লিজ। প্রথমে হিরণময় মিত্রকে, শ্রী হিরণময় মিত্রকে স্বাগত জানাই আমরা। তারপর আমাদের সোমনাথ দা ও সুকমল দাকে ফ্লাওয়ার বুকে দিয়ে আমরা, স্যার প্লিজ। সোমনাথ দা, সুকমল দা। এবার ডেকে নেব সিনিয়র মোস্ট সায়েন্টিস্ট শ্রী শীতেন্দু মণ্ডলকে, ওনাদেরকে উত্তরীয় দিয়ে। থ্যাংক ইউ স্যার। উত্তরীয় দিয়ে আমরা স্বাগত জানাবো। হিরণময় দা, প্লিজ। থ্যাংক ইউ। বাকি দুই আর্টিস্টকেও আমরা উত্তরীয় দিয়ে সম্মান জানাবো। সোমনাথ দা, সুকোমল দা, থ্যাংক ইউ স্যার। এবার আমরা আমাদের প্রোগ্রামে চলে যাব।
একটু দূরে এগিয়ে বলো তো। নমস্কার। গুরুজি এবং সকল গুরুদের প্রণাম জানিয়ে আর আমার সকল সহকর্মীদের ভালোবাসা জানিয়ে আমাদের অনুষ্ঠান শুরু করছি। দ্বৈত বাজনা, দুজনের মিলিত প্রচেষ্টায় আমরা অনুষ্ঠানটিকে সর্বাঙ্গ সুন্দর করার চেষ্টা করব। এই দ্বৈত বাজনার ব্যাপারে একজন পণ্ডিতজির একটি উক্তি আমার খুব ভালো লেগেছিল, সেটা আমি একটু শেয়ার করছি। শিল্পীরা যখন একক বাদন করেন তখন অনেকটা ব্যাচেলার লাইফ, ওনার স্বাধীনতা, যেভাবে ইচ্ছে উনি বাজাতে পারেন। দ্বৈতভাবে যখন আমরা বাদন সম্পন্ন করি সেটা একটা ম্যারিড লাইফ। সো এখানে দুজনের মধ্যে বোঝাপড়াটা একটা খুব খুব জরুরি। গুরুজির তত্ত্বাবধানে আমরা সেরমভাবেই কতগুলো বোল চয়ন করেছি পরিবেশন করার জন্যে। ব্যাকরণ মতো সবকটাই আমরা বাজানোর চেষ্টা করব। শুরু করব একটা নমস্কারী টুকরা। নমস্কারী টুকরাটা হচ্ছে একটা বাদ্য অঙ্গে গুরুজির প্রণাম। নমস্কারী টুকরার পর আমরা একটু পেশকার বাজাবো, বাজিয়ে 3 তাল বাজিয়ে সঙ্গে সঙ্গে আমরা কিছু কায়দা রেলা, তারপরে টুকরা চক্রধার দিয়ে আমাদের অনুষ্ঠান শেষ করব। সকলের অনুমতি নিয়ে আমরা অনুষ্ঠান শুরু করছি। শুরু করার আগে একটা জিনিস না বললেই নয়, আমাদের আজকের অনুষ্ঠানের সারথি হচ্ছেন শ্রী হিরণময় মিত্র, পণ্ডিত হিরণময় মিত্র। আনুষ্ঠানিকভাবে ওনার পরিচিতি আপনারা সবাই পেয়েছেন। ওনার সম্বন্ধে কিছু বলার আমাদের দুজনের বলা মানে ধৃষ্টতা। উনি আমাদের যে সময় দিয়েছেন, এই মাপের একজন শিল্পী আমাদের সঙ্গে রিহার্সাল করেছেন, এর জন্যে কৃতজ্ঞতা জানানোর ভাষা আমাদের নেই। আর একবার করতালির মাধ্যমে ওনাকে অনুধাবন করা। নমস্কার, শুরু করছি আমাদের অনুষ্ঠান। 3 তাল। আমরা একটা টুকরা বাজাবো, তারপরে চক্রধার দিয়ে বাজনা শেষ করবো। तेटे तेटे गगे तेटे गति गिने धा ता कते ता कते कते गति गिने धा कते धा कते धा धा कते धा कते धा धा कते धा कते धा। এবার একটা চক্রধার कत्ते घेगते कता कता घेगते कता घेगते कता घेगते धा घेगते धा घेगते धा कत्ते घेगते कता कता घेगते कता घेगते कता घेगते धा घेगते धा घेगते धा कत्ते घेगते कता कता घेगते कता घेगते कता घेगते धा घेगते धा घेगते धा। এবার চক্রধার বাজিয়ে আমরা আমাদের অনুষ্ঠান শেষ করছি, সময় প্রায় শেষ। ताकते ताकते कहते कहते कतक दिन तक तेरे कतक दिगिन धा 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 कते धा दिगिन धा कतक दिगिन धा धा कतक दिगिन धा धा कतक दिगिन धा धा ताकते ताकते कहते कहते कतक दिगिन तक तेरे कतक दिगिन धा 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 कते धा दिगिन धा कतक दिगिन धा धा कतक दिगिन धा धा कतक दिगिन धा धा ताकते ताकते कहते कहते कतक दिगिन तक तेरे कतक दिगिन धा 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 कते धा दिगिन धा कतक दिगिन धा धा कतक दिगिन धा धा कतक दिगिन धा धा।
ক্যা বাত, অসাধারণ মেলবন্ধন সুর আর তালের। কখনো কখনো গুলিয়ে যাচ্ছিল যে হারমোনিয়ামের সঙ্গে তবলার সঙ্গত নাকি তবলার সঙ্গে হারমোনিয়ামের সঙ্গত। তো অসাধারণ। আমার আন্তরিক শ্রদ্ধা ও প্রণাম আপনাদের সবাইকে। আমাদের প্রোগ্রাম মোটামুটি এখানে শেষ, কিন্তু শেষ নাহি যে শেষ কথা কে বলবে। শেষ কথা বলবেন প্রফেসর ইন্দ্রনীল মান্না, উনি আমাদের মাঝে আছেন এখানে। তো তার আগে একটা ছোট্ট বিরতি আমরা নেব, চা ফর টি ব্রেক। কিন্তু আপনাদের সকলকে বিশেষ অনুরোধ যে আপনারা ঠিক 10 মিনিটের মধ্যে ফেরত আসুন চা খেয়ে। আমাদের পাশে কেডি শর্মাতে চায়ের আয়োজন আছে, 10 মিনিটের মধ্যে ফেরত আসুন। এবং এরপর আমি স্টেজ হ্যান্ড ওভার করবো ডক্টর বর্ণশ্রী চন্দকে ফর আত্মারাম মেমোরিয়াল লেকচার। একদম সবাই আফটার টি একদম চলে আসবেন কিন্তু প্রফেসর ইন্দ্রনীল মান্নার লেকচারের জন্য, প্লিজ।
লাইভে আছেন তো?
Hello, 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 hello. Mic testing. Hello, 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 hello. Mic testing. শোনা যাচ্ছে? হ্যালো, শোনা যাচ্ছে? ঠিক আওয়াজ আসছে?
কথা বলো, বলছো?
হ্যালো, হ্যাঁ শোনা যাচ্ছে ঠিক? হ্যাঁ, আচ্ছা।
বেশি কিছু?
হ্যালো, 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 হ্যালো।
হ্যাঁ বেশি কিছু। বলো।
হ্যালো, 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 মাইক টেস্টিং, মাইক টেস্টিং।
ভিডিওটা একটু অফ করে দেবেন, অন থাকবে এখন? ভিডিও মাইক অন থাকবে না অফ থাকবে? দুটোই মিউট আছে, হ্যাঁ ভিডিও অফ আছে আর মাইকটাও অফ আছে। যখনই রেকর্ডিং চলছে, এটা হয়ে গেলে আমরা অন করে দেবো। চলছে, হ্যাঁ। দেখছি তো। আছে কোনো কথা লেকচারটা এইটা মনে হচ্ছে।
সোমেন এটা সে আনফ্রিজ করে দাও। তুই একটা পেজ
করবো কি করলে তো চেঞ্জ হবে না।
Electrician.
হ্যালো 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 চিক হ্যালো হ্যালো এটা চেক করে ওটা দেবো হ্যালো হ্যালো চিক ঠিক আছে হ্যালো হ্যালো চিক হ্যালো চিক হ্যালো হ্যালো চিক হ্যালো হ্যালো ফিডব্যাক আসছে হ্যালো হ্যালো চিক হ্যালো 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 চিক হ্যালো হ্যালো চিক হ্যালো হ্যালো চিক হ্যালো হ্যালো চিক হ্যালো 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 চিক চেক হ্যালো চিক হ্যালো হ্যালো চিক হ্যালো হ্যালো চিক চেক hello, check, hello. Hello, check, hello.
শিল্পী এবং যত কমিটি মেম্বার্স আমাদের আছেন তাদের অনুরোধ করছি একটু আপনারা যদি স্টেজের উপরে আসুন তাহলে আমরা একটা গ্রুপ ছবি তুলে পরবর্তী অনুষ্ঠানটা শুরু করতে পারি। আমাদের ডিরেক্ট হ্যাঁ
জয়ন্ত জয়ন্ত মামসি মৃণাল
Welcome back, everyone. I'm sure everyone has enjoyed the splendid cultural program. So now I request Mr. Shitendu Mondal, Chief Scientist, CSIR-CGCRI, Mr. Siddharth De, Controller of Administration, CSIR-CGCRI, our Director, Sir, to accompany our Chief Guest, Professor Indranil Manna, to the dais and take their seats. So now moving forward for the 21st Atmaram Memorial Lecture 2024, I request our Director Sir to present few words on the 21st Atmaram Memorial Lecture.
Good evening once again to each and everyone, our respected chief guest, Professor Manna, my distinguished colleagues here, students and ladies and gentlemen. So this is once again after the wonderful musical programs. I think programs is very difficult to come to this programs. This is a Atmaram 21st Atmaram lectures. Let us welcome this Professor Manna, who is already the ex-director of this institute. Probably you know that. So let us not wait for this for further times. Welcome once again and please continue. Thank you.
On, right? Hello? 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 Is it okay now? Hello? Okay. Yeah, so good evening, and so Dr. Murmu and all colleagues of CSIR-CGCRI, in particular Shitendu, Mr. Dey, and all of you, I certainly am indebted that you thought of me to share with you some of my thoughts on this very important occasion of Atmaram Memorial Lecture. Anywhere in the CSR platform, the name Atmaram evokes a tremendous amount of respect, adulation, and particularly in CGCRI, where actually he started his main career journey. He's more than an icon, he's almost like an idol before all of us, for the sheer volume of work and example that he set and left behind. So I think each scientist anywhere in CSIR system, and in particular in CGCRI, always would like to emulate the tremendous amount of excitement and examples of translation he has left behind. I particularly would emphasize the translation because his initial training was as a chemist, and then subsequently what he delivered during his long career profile is even very difficult even today to replicate, to repeat. So he always would continue to inspire us and set us an example before us as to what is possible within the CSIR system. And please remember that we are talking about an individual who served or who established this institution 75 years ago, or started the journey even earlier than that. Now, I chose a topic which actually is, in my opinion, fairly pertinent and also provocative. That's because we are all aware that the whole country believes, particularly the Honorable Prime Minister, he has ordained us to charter a path. I mean, we were happy celebrating the Amrit Mahotsav, the 75 years of India's independence until 2022. And everybody thought that this period is over, so now we can relax. But even before that period was over, the Prime Minister declared that now the next 25 years should be the Amrit Kal, which essentially means that India now has embarked upon a journey to emerge as a developed nation, Viksit Bharat, by 2047. A very legitimate ambition for a nation which by now is the most populous state in the world and also happens to be the youngest. So combining these two, it's only very logical to expect that India, which is almost 1/5 of the humanity, should emerge as a developed nation, and that naturally would make a huge difference to the entire world. Now, we live today in an era of knowledge, no longer by force. So nobody wins any battle today by force. It's basically the gray matter which allows you to win any battle or any challenge, not just a physical threat from an enemy, but even scientific and technological challenges. So how do we forge ahead? How do we move on? I'm going to share some of my own perspectives about that. So that's the whole idea. But I consider this to be a very, very big privilege and honor to me, because when Dr. Murmu sent me the invitation, he also sent me alongside a list of the previous Atmaram Memorial speakers, and starting from Dr. Mashelkar to the current Director General, there are so many eminent people. So naturally, you do feel a bit of butterfly in your stomach that such were the people who delivered this lecture. So what am I going to speak about, and how much sense does it make to the audience? Let me also, courtesy demands that I should mention that I can wear two hats in my professional life at the moment. I still have my position retained at IIT Kharagpur, and incidentally, it's hard to believe that this is my 40th year in the profession. I mean, I myself find it very difficult to believe. So, apart from IIT Kharagpur, for the last 4 years, I'm associated with Birla Institute of Technology in Mesra, one of the oldest institute of technology post-independence era. To be precise, it's actually the third oldest, going by the name Institute of Technology. The first one was BIT Sindri, Bihar Institute of Technology Sindri, IIT Kharagpur, 1951 and 1955, Birla Institute of Technology. I'm not considering the ones which are Institute of Science and Technology or Technological Sciences or something like that. And in addition, I also am extremely honored to be part of the Indian National Academy of Engineering and of late Indian National Science Academy. And you also will see that Dr. Atmaram was president of Indian National Science Academy very early age, at a very early time. So I don't need to repeat the entire biography. Incidentally, I was very privileged to write a column on Dr. Atmaram for the CSIR. CSIR now has decided, the current DG CSIR has decided that they would like to have a volume published with the profile of each of the Director General, whoever served the CSIR as DG. So she requested me to write on Dr. Atmaram, and Debashish helped me and several others from this institute and whatever other resources I could lay upon. So I went through that, and then during this writing this article, I realized that what a towering personality he was. It's not because just he was director, or he started this, pioneered this laboratory, or went on to become the 4th Director General, or was president of INSA, president of International Glass Association, Commission on Glass, and so on. It's because starts with a very humble beginning, coming from a distant village in western UP, studies in Kanpur and Allahabad, acquires very laudable landmarks of his educational career, and then ends up in Calcutta working as a research associate for a while in the test house, and then because of his expertise in experimental research, Dr. Meghnad Saha picked up a liking on him through, of course, Professor Dhar. And that's how he was given charge of this project to create a laboratory on glass and ceramics. In the morning I mentioned it was all because of Dr. Meghnad Saha that CSIR decided, BSIR and then subsequently CSIR decided that India should have a dedicated laboratory on glass, on optical glass and specialty glass. And the onus fell on Dr. Atmaram to be the project leader. And eventually, after he started, within about 2 or 3 years, he was made a full-time director. So was his dedication that he, during his training in Germany, he actually met with an accident, lost one of his eyes, but that didn't deter him to continue. In fact, he came back even with more dedication and commitment. And I think it's part of, you certainly have, you are either aware or you will read that article and figure out as to what all he did in his landmark. So what is important here is that while I speak on Dr. Atmaram, what is important as a former employee of this institution is to not just pay homage as a part of a ritual, but to remind all of us here what dogged dedication and commitment can achieve within the lifetime of an individual. So whenever we talk of CGCRI, there are a few output or outcome products that we take pride in mentioning. One of them is radiation shielding window glass. To a large extent, I mean, incidentally I was present that when the final consignment was supplied to DRC, but actually the project began 40 years before, and when Dr. Atmaram was very, so he's a man who had a vision to start a project which eventually made India self-sufficient in one of the facets of atomic energy research and nuclear power harnessing. Anyway, there are many more such examples. I will rather skip those for the paucity of time, and would like to again take a few moments to share with you our national pride that this country achieved approximately 1 year ago, just 23rd. In fact, all of us are aware that Government of India has declared August 23 as National Space Day. We have National Science Day, National Engineers Day, National Technology Day, and now Space Day. Now, why is it so important? That's also something that deserves a short mention. That we touched the surface of Moon is not only important because we were the first nation to land in the Southern Hemisphere. Now, of course, it's very important because rarely we get an opportunity where we celebrate something where India is the first. I mean, it's almost like getting gold in Olympic in a particular discipline. So we don't get very many such occasions to celebrate. Here is one such example. And why is it important? Because it's not curiosity driven anymore. It's actually necessity driven, not just for communication, not for going from 4G to 5G or 5G to 6G. It's more about understanding the origin of life. Where did we all come from? I mean, if we can ride a time machine and go back 13.8 billion years ago, then that was a time of approximately when energy and time were all confined to an extremely small domain. And that's when the scientists believe the universe started expanding. And that's what we call Big Bang. So at that point of time, there was no CGCRI, obviously no India or no other country. All we had were the quarks and the electrons. Not even protons. So from that, we started making protons and neutrons, ions, and then neutral atoms, molecules, aggregates. But they were all either in the gaseous or the plasma state. And eventually, the cooling started many millions years after, gradually. And that's when all the planets and stars and constellations, galaxies started forming. And even today, nobody can exactly claim the dimension. So the origin or the importance of this entire event is that you're looking at the length scale from the two possible ends. One is the largest possible length scale in terms of time and distance. And on the other hand, you're also looking at the origin of matter or life from the smallest possible length scale, where all energy converted into matter. If you are interested, or if we are interested, know that why this is important, because it's very much related to our existence. So then we have to figure out, or at least understand, either through simulation or maybe some other exercises, that how did these aggregates started forming and came to this being. Now on Earth, if you want to do something similar, then you have to create simulated conditions of zero or microgravity, very rarefied condition, temperatures very different kinds of a time scale and length scale, which is very difficult and expensive. So this is exactly why NASA and European Space Agency, they already are running international space stations. So now ISRO is not doing for fun. ISRO basically wants to also follow the same path to go and establish station. And I had the privilege of talking to Chairman ISRO, and I was surprised to hear that he says that the work is very much on, and India actually is going in great strides towards sending manned mission to the outer space. Now, when you send a satellite, it's one way. You send a rocket, you defy gravity, install the satellite, it keeps on giving you data, information, helps you in very many things, monitoring. And then at the end of the life, that just is dead and still remain positions at the same location. You don't bring it back. But when you send a human being with certain payloads and you wish to bring it back, then you actually have, so it's a two-way trip, then you have a very different scheme altogether. And that's not very easy. It's certainly one of the most difficult tasks one can think of today. But the question is, if other nations are actually already doing, then why India cannot? And that's why National Space Day is very important. So why I mentioned about National Space Day is because success in Space Odyssey is a system solution, is a success of a complete system engineering. Now, Viksit Bharat, in my opinion, also requires certain system approach, not individual approach. For example, in CGCRI, if you say that we produce an excellent glass fiber and we are very happy about it. Now, who is going to make a device out of it? Who is going to actually make sure that this device is better than what is available in the rest of the world? The same way that whatever we do, so in this journey, I mean, we are scientists and technologists or engineers, so obviously we cannot solve all the challenges faced by the nation, but anything related to energy, habitat, transportation, climate, water, these are absolutely the domains where we have relevance, we are supposed to contribute. So in order to do that, we tend to say science and technology. For example, we have Department of Science and Technology. I often feel that, is it so logical to believe that what you demonstrate as scientific truth is immediately translated as a technology which is selling in the market? You need a very important bridge in between, which is engineering. Otherwise, you rarely have a solution which actually goes straight into the market. So I use this cartoon to actually explain this thesis. I say that nobody has ever seen whether an apple actually fell on the head of Newton. But we all know and would agree, he was the first one who ever raised this very fundamental question as to why should an apple fall and not fly onto the sky, towards the sky? Why is not the other way around? And the culmination of that is the famous gravitational wave. And the gravitational wave is actually universal gravitational wave, not just on the Earth's surface, and which is what is the foundation for any of the activities that we see for anybody trying to not just fly, but even defy the gravity. Now, birds fly, so a very pertinent question is that why can I not fly? If this small animal could fly, what prevents me from flying? I'm supposed to be much more clever than a crow. So Da Vinci drew this sketch in 1600 something. And it took humanity 200 more years, 300 more years in early 20th century to demonstrate the first man-made flying machine which flew only for less than 20 minutes. So humanity had to wait 300 years to see whether whatever Da Vinci drew, borrowing the inspiration from Newton's relationship, could actually be translated into an object which proves that it is possible. So we tend to believe that in order to do, so in my opinion, what Newton proposed is a fundamental answer to a fundamental question: why should an apple fall and not fly into the sky? What determines the direction of any object on Earth's surface to fall onto the ground? Da Vinci created certain sketch that this is how, if you can create an aerodynamic force, you actually can keep yourself flying. And the demonstration came by the Wright brothers in early 20th century. So we tend to believe that from know why to know how, and eventually to know what is the successful technology, the sequence is science, engineering, and technology. Now, we all know that Einstein, in fact, there we have an element of pride because in many cases, our own Bose's name also is echoed along with Einstein. The moment we talk about the fundamental particles or fundamental forces related to matter. But when Einstein predicted gravitational wave in 1916, it was proven scientifically, mathematically. It took exactly 100 years for humanity to prove that gravitational wave does actually exist, when LIGO experiment was successfully able to provide the correct evidences, scientific evidences. There are many such examples where certain predictions require specific technological intervention to be proven correct. I can borrow from my own subject domain an example called Grenier-Preston zone, GP zones. Those of you who are interested in high specific strength materials, you all know that the bulk of the aircraft is made out of aluminum alloys. And it's not because anybody is fancy, it's because of a particular reason that aluminum alloys is very ductile and fabricable. So you can easily fabricate, but then if you subject it to a certain thermomechanical or thermal treatment, then it acquires strength which is more than double than in its anneal condition. So this happens due to a particular phase transformation, which is called formation of zones or coherent precipitates. This was proven and tested and proven in 1929, 30, in that range. We had to wait for 30 more years till the time electron microscope came to being and powerful X-ray diffraction techniques emerged to prove that GP zones actually exist in such age-hardenable alloys. So we do see both ends, that technology also proves that scientific predictions are correct. So you need both. Now, in order to do that, this is a very favorite slide of mine because I firmly believe that this is exactly the basis. So I said science is know why, engineering is know how, and technology is know what sells in the market. So what it means is that just like a typical diffraction pattern, you see peaks at some distances apart, but rest are all background. So we continue to try to lift the knowledge base of the society, but once in a while some very major discoveries occur, and that discovery is actually a scientific discovery which gives very fundamental clue. Engineering is translation of that clue. So when you apply potential difference across the wire of a conductor, electrons flow, you get electric current. When you apply the same condition onto a non-conductor, there's no electrical current. So why in copper wire we see electrical current flowing, or aluminum wire, but when it is alumina, there is no current flow? Why does it happen that way? So that's exactly the fundamental truth that Faraday first said, but it took the genius of Edison to prove that you actually can make an electric bulb or incandescent bulb using this fundamental truth. But you need organizations or individuals who actually take it to the marketplace so that you and I can derive the benefit at an affordable cost. So that's the ultimate technology. So this is a cycle which continuously goes on because of this very reason, that the academia produces knowledge. By academia, I mean the entire scientific fraternity. The research organizations, they find out the path of invention, and the industry owns them and translate them into a viable product. That's what we call a technology. But then the story doesn't end there. The story is perpetual. or the cycle is perpetual. Why? Because the cell phone that we carry today, the day I buy, I'm very happy that I have the top of the shelf equipment, and I flaunt it in front of my friends that look, I have this phone 15, 16, 17, whatever. In no time, another 6 months, you have another 20, or next another 6 months, another 21. Why does it happen that way? Because if you have finite resources, you always would like to buy the best, the cheapest, the smartest, the most energy economic, recyclable, whatever attributes you can think of. Whatever resources I have, budget I have, in that I want the best possible solution. So this is what the society demands. And this is what drives the perpetual cycle of science to engineering to technology to marketplace to, again, back to science, again, and so on and so forth. But as I said, this is not necessarily sequential. It can also happen not exactly in the same sequence, but in another sequence. Eventually, this is how society progresses. Now, if we talk of Viksit Bharat, India, this is also a very favorite slide of mine, because I firmly believe that India is a very heterogeneous composite landscape. Every 100 or 200 kilometers you travel north, south, or east, west, from the complexion of an individual, the features, the physical features, the language, the food habit, the way the same religion is practiced, the attire, everything changes. It's pretty much like Europe, where you have so many nations within a certain landmass. Now, India is actually 3% of, nearly 3% of the entire Earth's landmass. And it has a cultural boundary which is beyond the geographical boundary or political boundary that we see. I mean, you hardly can distinguish people from South India from those who live in Sri Lanka. You hardly can differentiate between people living in Calcutta from those living in Dhaka. Likewise from Punjab and Lahore. So, first thing, if we want to make a difference to the country, in my opinion, the brightest example is none other than who lived in this city more than 100 years ago, Swami Vivekananda. So, at the age of 25, he decides that he should know the nation. He wanted to do good to the nation. And so he realized that unless I know my people, how can I do anything good for them? So what did he do? He didn't buy a car or book a ticket in aircraft. He took a journey by foot all the way throughout the entire country with no resources, no money in the pocket, alone, and managed to reach all the way to the southernmost point of the country. If any one of us ever do that, even today, the amount of understanding that will develop about our own people and own country, not just climate or weather or complexion or food, but about the psyche of the nation, you cannot imagine any other parallel example. So I picked up certain iconic figures over a large length scale. Kanad, 600 BC, talks about Anu Paraman. I could have picked up very many such faces, but I just picked up from the yesteryears. Then, quick ahead, Ramanujan's conjectures, people say that there are many more which are still unresolved than the ones which were resolved. So such was the power of this genius. Our own Satyen Bose didn't think it was necessary to do PhD, but his insight in physics was so great that Einstein recognized sitting far away from India. In the recent times, I picked up Ashok Sen, but there are many other scientists. Someone may argue that why Ashok Sen and why not somebody else. So with this background, now let's look at some data point. In fact, whenever you would like to make a journey from A to B, it's very important for us to define where is A and what is B, so that we can define both the magnitude and the direction needed to transform. we take pride in saying one of the oldest civilizations, 5,000 plus years old, and it's also true that until 1700 AD, that means just about 300 years ago, India used to be one of the richest nations in the world. I mean, absolutely documented. So apart from the large landmass, size, area, population, fifth largest GDP, or in terms of purchase power parity, almost the third largest, with fair amount of GDP growth. I'll come to those data points later. What is also very important is that I don't know whether all of you are aware, I personally was quite surprised when he figured out the 2 lines that I wrote on red. The largest drug and pharmaceutical industry market is India. The second largest producer of steel, India. Cement, coal, telecom, food and agriculture. We occupy the second largest position in the world. The third largest generator of electricity, producer of electricity as a nation. The third largest civil and real estate business in the whole world. The fourth largest auto manufacturer, mining and minerals producer, 9th largest civil aviation market. I mean, a country with this sheer volume of population, length, and resources has to be front runners in many of the things. These are just a few. But there's a flip side, like you always have a flip side of the coin. The flip side is that we may be 5th largest economy in the world, but per capita income is very paltry, about $2,500 a year. I mean, in terms of the Human Development Index, the people below poverty line, the literacy level at the tertiary level, there are many other things which actually are not very glorious. So if we are truthful and if we really want to achieve what we are claiming to achieve, then we must know where we stand. What is A? And where we want to go, where is B? So in my opinion, the challenges, whether it's poverty, hunger, healthcare, various security threats and so on, both cyber and physical security, they're all to a large extent related to engineering and technology. So we wish to chart our path, as I said, A to B. And I picked up from the available resources 10 parameters: economics, demographics, political system, education, so on and so forth, and wanted to see where we stand in terms of where we are and in terms of where some of the nations who are ahead of us, where do they stand today. So I picked up obvious reasons: US, China, South Korea, Sweden, a tiny little nation, Sweden. Now, as you can see, in terms of the GDP, we certainly have a mighty, some people claim it's over 4 trillion now, the 5th largest. So obviously we have reasons to be proud. The growth rate is by far the highest among all these nations, whether it's 7 or 6% or somewhere between 6 and 7, that's debatable. But what is important is higher than any of these nations, including some of the nations where the growth rate is actually negative. But the income per capita is something which is abysmally low compared to, say, you don't have to look at US, but even compared to China, it's less than 20%. And obviously, when you go eastwards or westwards, there are nations where this number is much higher. The inflation rate also is a matter of concern. You ask any economist, they'll say that GDP is only one side of the story. Even per capita is not enough. The inflation, what you have today, what is it is worth tomorrow, is a very important economic parameter. And that is somewhere around 5 or 6%. At times, RBI announces that no, last quarter we did well, last 2 quarters we did well. But then it is still a matter of concern because this inflation times the number of people and their income, if you add on, is actually a very major number. The unemployment rate exists anywhere in the world. There's no country which claims 100% of the able workforce is all employed, and this probably will never happen, but it is high compared to the nations that we have chosen for comparison. The unemployment rate is again on the higher side compared to the nations that we are comparing with. Labor force participation rate. Now, this is a very important parameter. What it says is that in India, out of 100, 40 or 42 persons are able to find some gainful employment, compared to 60 and above in US, 70 or 75 and above in China, about 70 or 63 in South Korea and Sweden. So that means a large workforce, percentage-wise, is looking for gainful employment. And now when you look at or you multiply with 1.41 billion, so whatever it is, 40% or 60% of 1.4 billion, you can imagine what large number we are talking about, who are still looking for jobs. We are happy and proud that we have diversity. In fact, when I showed you that collage, you would have seen somewhere on the top I wrote that I borrowed what Tagore said. I mean, I can't find a better definition of India than this particular statement. Unity in diversity. We would have heard this many a times. What does it mean? It means that, yes, we have every 200 kilometers is very diverse. We see a very different landscape. But yet, we are bound by a common thread. And that common thread is at times religion, at times language, at times food, at times certain cultural activities, whatever it is. But the diversity is unmistakable. China speaks one language, South Korea speaks one language, Japan follows. The written form is slightly different, but basically one language. Sweden, Scandinavian countries, at least Sweden is one single language, though they have minority language. India has 22 official languages. This 350 number that I've quoted here, these are variants, these are not languages. They don't have a separate grammar or alphabets or anything of that sort. For example, we all know that typically if you are today, if you are in, suddenly you land up in one of the southern states, and you are traveling in a taxi and the driver, you have to explain the direction, you know very well what kind of a nightmare experience you may have. The same thing happened to somebody coming from south to a northern state, and he doesn't know Hindi. So this is the reality. The population, I already told you that China and India today is the two most populous states. But what is even more important in case of India is that we have a positive growth rate, and we are the youngest nation in the world. So average age of the population is below 30. Now, any European, Scandinavian country, if at all they have to envy, they'll envy only for this reason, because they have a negative population growth rate, and the average age of population is, there are more people who are seeking pension than the number of people who can work and generate that pension. No matter what, I don't know if there's anyone in this hall or elsewhere who would like to trade the political system that India has, despite all these street protests and hold-ups and many disruptions, with that from China. I mean, it has its own advantages because the pace at which they can implement a reform is phenomenal. I've myself experienced this in Singapore. If a university decides to change something, they take 1 day to declare. And if they decide that it is not going to work, or for whatever reason it is not advisable to implement, they'll withdraw the very next day. No questions asked. In India, before even you open your mouth, there are at least 10 articles written on the newspapers. But still, we have swallowed it for so many years, and I don't think we would like to trade for anything which is absolutely dictatorial. We don't want that. So we are happy being in a very democratic system, and also which is secular and entirely we work as a republic nation with so many 29 states and 9 union territories. Education is a matter of real concern, at least because I come from academia. You know, many years ago, I again will take an anecdote. We all are absolute disciples, or particularly in Calcutta, disciples of Subhash Chandra Bose. Netaji is, I mean, undoubtedly the hero. Netaji wanted to throw the British away by force, and he created Bengal volunteers. If you go into the history, you will see many references to that. So he went to Tagore, to Shantiniketan to seek his blessing, said, Gurudev, you have to come and bless this youthful enterprise and so on. So Tagore had obviously a lot of affection for young Subhash, but he was ill, so he couldn't travel. Instead, he wrote a line as a message. And I heard this from my father, so I don't know whether how far it's correct, but that's what I heard from him, that apparently Tagore said one very simple sentence: build the character of the nation, the British will automatically go. I cannot find a more appropriate definition as to what as a nation we should do. Most of the things we see in the country in the last 70, 80 years, 70, 75 years are all top dictated. Government announces 5 IITs become 23 IITs. Government announces such and such project is going to happen. We have very rarely seen a situation where the common man decides and agrees that every child in every family should get school education up to a certain level. Only when government announces midday meal or something else and something, they try to win over and send them, because they're fighting for their survival. We haven't been able to create a situation, though we claim we are 100% in primary level, GER 93% or above. So in my opinion, gross enrollment ratio is a very major concern, particularly in the tertiary level. You go to small or big countries, I mean, the level of education is phenomenally better. And when I say education level, I don't necessarily mean degree. I mean ability of an individual to think independently and decide. We are far away from that. And we are concerned because of this figure at the bottom. Government expenditure on education compared to 5 to 6% in China, 4.8%, 5 to 6% in USA, 4.8% in China, 4.5 to 5% in South Korea, and 6 to 7% in Sweden. We have 3.5%, and that includes to a large extent the infrastructure expenditure for primary education. There are plenty of villages we don't have schools or buildings, or even if we have, people are not getting their entire salary or something. I mean, there are examples. I'm not saying the whole country is like that. I must also acknowledge that the country has made enormous progress in the last few decades, but we are far away from being complacent. We cannot afford to be complacent. We have about 1,200 universities in the country, including the state, private, and whatnot, more than 1,200 under UGC. And we know very well that in terms of global ranking where we stand. And we cannot be all the time blaming that we don't have money, we don't have money. I mean, when will we actually be, if we want to compete with the rest of the world, then we have to build that infrastructure, we have to build that capability. Life doesn't exist without energy, we all will perish. So, you know, some years ago, India's energy requirement was about 300 to 400 gigawatt hour electricity. Today, we are looking at 650. At the moment, if India, and we consume approximately 20% of the world average. I'm not comparing now with US, Russia, or China. I'm saying the world average, if it is X, per capita electricity consumption in the country is 0.2x or maybe 0.3x, far below than the world average. If you want growth, there's no growth without energy. And 2/3 of our energy production is still hopelessly dependent on coal or natural gas, all carbonaceous energy materials, which are all finite, is bound to perish, bound to get completely exhausted someday or other in the future. Government made very strong strides in terms of forcing companies, states to go for renewable energy resources. What was hardly a few percent today is nearly 20% or more. So the total renewable component in the entire energy production seen in the country today is nearly 30 to 40%, I mean, to that extent. But that, of course, includes solar, hydro, wind. Nuclear is paltry, 2% or less. But why is this mix still not favorable to our country? In fact, solar, we tend to believe, is a solution provided we have certain things. Say, for example, there's a nation in the world, in South America, who claim that they're going to completely take care of the dependence on gasoline by biofuels produced from agricultural products. How much land do you need if today, if the total consumption of petrol is X, million gallons or whatever, if you have to replace that all by biofuel, how much crop field do you need to have ponds? And then where is the land left for producing your agricultural products, your rice and maize and wheat? So a solution has to be seen in totality, not in isolation. That's why I use the term system solution, system engineering. We have to look at the entire cycle. For example, many times you'll see that companies claiming that we are completely renewable energy based or something like that. Say, for example, if you say that I'm producing this, I'm running a car by electricity, so I'm eco-friendly. The next question you should ask is, where is this electricity coming from? How did you produce that electricity? For charging the battery, are you using the grid power? Is that coming from your nearest thermal power station? So we have to make that. And if I want to convert everything 100% solar, do I have so much of land mass available where I can put up all the panels? And please remember, the panels have a finite life. And we haven't completed one full cycle. After 10 cycles, when we have so much of panel, today I was trying to solve the problem of one of my close relative. She wanted a television in place of the older television. And the older television happens to be the CRT, old model, big cathode ray tubes television. There is not a single shop owner in the city who is willing to take it back. And she said, I'm going to give you free, even give you the transportation cost. Nobody is willing to take that. So when technology moves at such a rapid pace, you also have to think of the recyclability and utilization of your resources 10 years, 20 years, 50 years, 100 years down the line. What will happen? So we have major challenges there. I'll just skip some of these things. It's not very gratifying to see that India, being the youngest nation in the world, occupies 40th position in terms of global innovation index. Recently, I had the privilege of visiting Helsinki, 5th or 6th in the world. Sweden, number 1 in the world. What population? Less than Calcutta. They're the most innovative nation in the whole world. We haven't innovated well. We haven't created the culture of innovation well. Of course, infrastructure and so on are a matter of healthcare is another major issue. We all want to be safe and healthy. We have done well. India has done reasonably well. I'm going to also show you some more interesting data to prove my point in terms of life expectancy, in terms of child mortality, infant mortality at birth or after 5 years or something. In all cases, India has improved over a period of time, but far low compared to our, in terms of scale wise, we are not comparable to the rest of the world, at least the examples I have picked up. That's because the percentage expenditure, percentage GDP spent on healthcare in the government by this government, by the successive governments since independence, at best now is at 4.5% compared to 18, 7, 7.8, 11% of the developed nation. So that also needs to be raised substantially. I'll just skip some of these parts because, but now is another comparison. Where we started, 1947. 50 years from that, 1997. 25 years from that, 2022. And at the final destination that we are thinking about, 2047, where will we be? The GDP will look even more formidable and respectable. You see, what is interesting is 2.7 trillion, this is in rupees, not in US dollar. So 2.7 is 34.3, 262, 2144. What it means is that it took 50 years to go raise or increase by 1 order of magnitude. It took 25 years to go by 1 order of magnitude up, and will take another 25 years to go another order of magnitude. So 4 orders of magnitude in 100 years, but rapid progress now. So we are actually on an upswing. Population is large, per capita income should reach a decent level of 12 lakhs per capita per annum by the time we go 2047. The enrollment ratio causes a concern. Now, this is secondary level, whereas this is tertiary level. Now, we claim that we have reached 27%, 28%, but I personally am not very confident whether this number is absolutely precise. But we claim that we should be reaching 60%. And tertiary means we are talking about post higher secondary in the college, university level. The child mortality rate is going to come down significantly, and life expectancy, which is now at about 69 or 70, will go to 75 almost. The growth parameters typically are measured. There are many possibilities. One of them is steel production. Now, you see that again, there we have a very similar story like the GDP growth, that order of magnitude in 50 years, another order of magnitude in 25 years, and 5 times than that in next 25 years. But I proudly said that India is the second largest producer of steel. What is that quantum? Less than half of what China produces. Much less than 1/4 of what China produces. If the world steel production level is at about 1800 million tons, India produces 125, 130. China produces alone more than 100 million tons, 800 million tons. And I've seen one plant in Korea, South Korea, Pohang steel plant. In one single plant, they produce 40 million tons, 1/3 of India's capacity. China, the Bao steel, more than half the world's total production. Now, we have a flip side here, that if India actually produces, ends up actually producing, the government declared 300 million tons more than 10 years ago, I thought. If India produces 300 million tons of steel, you multiply that by 2, so you're also producing 600 million tons of carbon dioxide. Can we afford to do that? Now, you see the dilemma that we carry. On one hand, we want more roads, buildings, houses, tall stadiums, and all big infrastructure. none of them are possible without steel. So we are a developing nation, so we consume more and more steel. In fact, per capita steel consumption, like I said, energy consumption is less than half of the world average, less than half. So obviously, and if you multiply by 1.4 billion people, then you see that what is a large demand we are talking about. So where are we going to go from here to the next? So now the question is that what are we doing as technologists and engineers and scientists? I know IMMT has been talking about hydrogen-based iron oxide reduction for decades, ever since at least I studied metallurgy. The solution doesn't exist anywhere in the world. CGCRI has demonstrated solid oxide fuel cell not today or yesterday, decades ago. Where are we in terms of commercialization? Now, it's very easy to point fingers or preach. It's not so easy to demonstrate. That's why I was, before this occasion I was talking, I said, if you have slightest resource, run a plant and run it only for the sake of showing it to the rest of the world that we are running. I've seen Bloom Energy, they actually run an SOFC just for nothing. They want to acquire the experience of what could be the problem associated with it. So what I'm trying to say is that we, as members of the learned society, if we only say that government is not enough spending, government is not pumping money or resources or something or other, the counter question somebody from the other side can raise is that whatever resources, whatever opportunities were created in last 75 years, are you sure that you have done enough justice to that? I don't think we really have a very, if we place search our soul, I don't think we have a very convincing answer. And this is something where we have to be very clear in our conscience. And that's why I said that, CSIR, for example, when we started Imprint, the very pertinent question was, we are an institute of technology, IITs. We are an international brand name. Anybody in the academia, anywhere in the world, knows these abbreviation, IIT. What does it stand for? How many technologies have we developed? How many technologies we have delivered? Very few. We would have contributed enormously. But where is that final stamp that, yes, this was made by IIT A, B, C, D, whoever? The same thing, there are many examples in CSIR system from this very laboratory where we have made a difference. But why are we stopping there? Why are we not taking, today morning I gave you this example of this water purification device. One thing I've done, you'll be all surprised. In VIT Mestra, about 10,000 people live on campus. About 5,500 students, 350 faculty members, about 500 non-teaching staff, their families. We have easily more than 10,000 people living in that small area, small so-called township. Not a drop of water comes from the municipality. We lift water, we purify, and we circulate. When I joined, to my horror, I realized that every single household, whether the employee living in that household earns 3 lakh a month or 30,000 a month, buys water from the market to drink. I said, nothing can be more shameful than this. So Mr. Birla agreed to invest over 2 crore. We created an RO plant. And today we supply potable water door to door at a cost 1/10 of what sells in the market. Initially there was resistance, and there were, you all have very knowledgeable people everywhere. Somebody said, sir, what are you doing? You cannot sell water. If you sell, then government, such agency will slap a huge penalty on you. I said, I'm not selling water. I'm only charging a bare minimum as my utility cost. I need electricity, I need infrastructure, I need repair, maintenance, and so on. I'm charging only for that. The water is free. So you have to take certain decisions, bold decisions, when you actually believe that you are right. You need that conviction. So whatever Shivdas Bandyopadhyay and his colleagues created, I think Shachyo included, we should have actually gone to the market in pouches, taken permission, got hold of somebody to sell them in the market. You travel towards Diamond Harbour, in the train you see bottled water or pouch water being sold. Do they have a stamp? I'm not saying follow that example, but all I'm saying is that, you know, we also live in a cocoon of complacency. We have to break away from that. Anyway, so to come back to the core issue, that if I compare how we have progressed, you see, I mean, we certainly are making good progresses. I mean, number of colleges and universities, 700 odd at the time of independence, 10,000, now over 1 lakh, and it's going to be a lot many more. But still the gross enrollment ratio is less than 30%. Okay? Manufacturing, the country's economy, that's another very major concern. All of us, those who have education, should realize more than 50% of India's economy is supported by 18% of the educated class, primarily from IT, finance, services. More than 52% of the economy. More than 50% of the population contribute 15 to 16% towards the economy, the agriculture sector. You can't overnight change. And where is manufacturing? 17, 18%. Some people claim 20%, I don't know. And the Prime Minister says it has to be 30% right tomorrow. What are we doing? We are good in launching programs, but where is the output? We should take a hard look at that and see what have we done with regards to that. Anyway, so I think, Naresh, I always get carried away. I think I would have taken a lot of time already. No, I'll go quick now. I'll fast forward. I identified certain sectors and challenges as engineers and technologists, what we should be doing. I'm not saying you solve all the problem in the world or in the country, but we should concentrate as engineers towards some of these directions. Automobile sector. You look at this banana diagram, the so-called banana diagram, strength is inversely related to ductility. Everybody knows. So we have to, when we want to make very high strength, the ductility reduces. When you have super ductile IF steel, there's no strength practically. We need a good combination. So we have to go somewhere here. We have to go somewhere here. That's the dream. To have good strength and also good ductility. Good strength and also good ductility. So new materials, high specific strength materials. Electric vehicles, the whole drive is different. There's no IC engine, there's no internal combustion engine. So the drive, the various dynamic parts and so on, they have to be designed. And EVs carry batteries, they're very heavy. And it's not easy to replace, find a new battery which is going to be very light. So on one hand you gain that you're not producing carbon dioxide, you're not burning petrol, but on the other hand, you also are burning more energy, requiring more energy because you are driving a heavy vehicle. One of the, for all these drives business, one of the very major component is the permanent magnet. And we know very well that 95% of the Earth's deposit on rare earth is confined in only one country. If that country tomorrow plugs the supply line, then the world will have no other possibility of getting neodymium or yttrium or dysprosium and so on, all the rare earth elements. So the scientific community, it's not that we have to tell them, they already are working on it, but we have a long way to go before we can find a good replacement, viable replacement for neodymium iron boron kind of permanent magnets. Energy sector, I was telling you about the solar panels. You improve the efficiency of the current silicon solar panel by 2% or even 1%. Let's say from 29%, you make it 30% or 31%. You're talking about billions and billions of dollars. So not that the world over people are sleeping over it, they are trying very hard, but why are we also not doing that? Wind or other sources of renewables, and there are a lot of material challenges involved to make it lighter, make it corrosion resistant or erosion resistant, weather resistant, and so on. I mentioned about aluminum alloys, the workhorse material for aerospace. There we also need, when we talk of the high temperature component, we need superalloys which can work more than 1050 degrees centigrade. Maybe if you can run the engine at 1200 degrees centigrade or 1300 degrees centigrade, for the same volume of fuel, you'll fly maybe another 500 kilometers more. Or you reduce the ticket cost by 20% or 30%. I would just take a few more minutes to give you some examples. You know, I mean, you believe it or not, I actually, let me borrow what my wife once told me, that when I joined CGCRI, after a few days, maybe a few weeks, he asked me a very honest question that, you know, all my life I've heard you talking about papers. Now you talk about files. Where do they come from? So since 2010, I got converted from a paperman to a fileman. But believe me, even then, I still managed to do a bit of science and maintaining certain level of, I must say, personal satisfaction and integrity. You know, I served 3 years in CGCRI, 5 years in Kanpur, and 4 years now in IIT Mesra. No paper, no patent, no project, no product with my name in it. I always maintained my little group in Kharagpur. Now, Mithun became my student in CGCRI by default. When Devuda, without telling any one of us or taking permission from any one of us, decided to quit. So D. Basu disappeared, and Mithun by default came on me because I knew a little bit about that subject too. When I went to Kanpur, the same story. But all along, whatever little I did, I do have reasons to be satisfied with some of them. So here is an example. You know, when you talk of aluminum alloy, I told you that age hardenability is the reason why you reach up to 500, 600 megapascal. That's the key. Now, that's because we are talking about crystalline material where deformation is dislocation mediated. I mean, I'm sure there is, in this community, we understand these terminologies. If you transform yourself to another domain where dislocations don't exist and have no role, then what happens to the strength? With that, not me, I mean, many years ago, people started working towards creating amorphous alloys for structural application. Amorphous alloys are brilliant for functional applications, very many functional applications, for structural applications. So, I mean, if you just look at this figure, this is perfectly crystalline. So this is what I start with. And if you look at this and this, then you see it's perfectly amorphous, non-crystalline. So doing some synthesis, I could convert a mass of aluminum-based alloy completely into amorphous. And then they used many techniques of high-resolution microscopy, positron annihilation, nuclear magnetic resonance to prove it is not only amorphous, why and where from it turned into amorphous. So scientifically very exciting. And by the way, why this is novel is because there were examples of aluminum amorphous alloys with heavy dose of rare earth elements, okay, cerium, yttrium, and so on. But we decided not to pursue because rare earth is a problem. By the way, when I showed rare earth, I forgot to mention why I showed you that, because it's not that we don't have rare earth. We have resources in the southern sea and particularly in the Kerala monazite sands. We have Indian rare earth, but still there's a lot of opportunities for us to produce rare earth from the beach sand and so on. So without using rare earth, we could produce this kind of an amorphous structure. And if you simply look at these numbers, 1940 megapascal, typically this is the kind of strength parameter you quote from margin steel, right? I mean 2000 series or 3000 series, 200 series or 300 series margins. So aluminum alloy giving you strength of 2000 megapascal is unheard of. Okay? So obviously then next day I should send my nomination to Nobel Prize. I didn't do that because of one reason. The other part which is not mentioned here, it has no ductility practically. It's almost like glass, window glass. You have extremely high compressive strength, but no ductility. So what would you do with such aluminum alloy? So we went and then, this study continued. I'll just to tell you that 4 PhD students worked on this problem. We could improve the ductility and we could show that it has improved toughness under compression, but not under tension. Paid attention towards high temperature material development. I mean, this is another very phenomenal diagram we all refer to when we compare strength as a function of the maximum service temperature. So this would be the ultimate, right? Now here you see tungsten alloy or certain types of stainless steel, ferritic stainless steel and so on. Very high density. So when you're talking about applications where it's not strength or temperature alone, even density is very important because you are flying the object. So you cannot take tungsten or tantalum or something like that, which are very heavy. So then obviously comes CGCRI's role. Then you're looking at silicon nitride or alumina or silicon carbide, boron, borides and so on and so forth. So there's a lot of examples, and then with one of my students I actually tried to develop ferritic steel with basically iron, chromium, aluminium, what was the other one? 4 elements with oxide dispersion. And I'll just, without the microstructure, again I'll throw some numbers. So now here we actually could consolidate by 4 different techniques: normal sintering, then what were the 4? Pulse pressure, pulse plasma sintering, then high pressure sintering, and hydrostatic extrusion. And again, look at the numbers. I mean, fairly strong and very good materials in terms of hardness, elastic modulus for 4 different alloys, where chromium is to iron ratio was varied. So this again gave very good numbers and fair amount of ductility now. So you look at the stress strain curve, very respectable, no? You're talking about more than 10% ductility with 1400 or 1300 megapascal UTS. And with this alloy, which is the highest chromium content, you have 4% ductility and with 2000 megapascal strength. So these are the fractographs. So we made reasonable amount of progress, but by then actually IGCAR had a project with ARCI and one other company. So they actually have given this solution to defense. I don't know how far it's commercialized. This is something where the non-oxide ceramic group is very much involved in CGCRI. I thought that's why I would show you the radomes on the nose cones. Now I mentioned that why this is important and where CGCRI can make a difference. I mentioned about ISRO's ambition to go to outer space, manned mission. And when they want to come back, then at the point of entry into the Earth's atmosphere, the friction with the atmospheric condition will be so large that metals cannot withstand. The space shuttle which was carrying Kalpana Chawla became a fireball because the tiles fell off. And the tiles individually didn't have a problem. The problem was with the interface between the tiles. You know very well that you can't join alumina and alumina with alumina. Either you sinter, then you make a monolith, which you can't do because of the shape and other dimensional restrictions. So you use certain cement, which probably gave way, and as a result, the tiles fell off and exposed the metal, and metal immediately rose. I mean, temperature rose very high, become an oxidation of metal is an exothermic reaction, so it became a fireball. So we have a lot of room to develop new type of structural materials for high temperature. And one of my former student, who is a scientist in IMMT Bhubaneswar, Pradut worked on 3 possible solution approaches. So basic material was zirconium diboride silicon carbide. He alloyed with titanium carbide in one case so that the sintering temperature got reduced. And this is a very interesting science actually. Ti4 plus manages to go into the lattice of ZR4 plus and replaces, but is smaller in size, so increases the diffusion coefficient. As a result, the sintering happens at a lower temperature. So Pradut tried with aluminum alloy as a sinter additive, and also tungsten and tungsten carbide and titanium carbide as additives. So we got very decent results and published some good papers and so on. But as an academic, you can go only up to this. Mithun came all the way to airport to receive me yesterday at 12 o'clock midnight. So I thought I should show at least one slide from him. So actually why I'm showing this is because he did a very good work way back in almost 10 years ago. Why I'm showing this is that, you see, the composite we are talking about, boride and nitride. Now, you cannot create such a composite by a single process, because these are completely disparate materials. So he used a very innovative combination of boron nitride powders mixed with titanium Ti6L4V, and then allowed them to react. And during the reaction, so this dissociates and finds way to titanium boride, and also with titanium it also can form nitride. So in situ formation of a composite on a thin layer. So very good work. I don't know how much he did after that, but it certainly is a very important contribution. So what I'm trying to say is that when you develop, you don't necessarily concentrate only on the bulk. You also should talk about the surfaces. So these are the surface damages that we always dread of, at the turbine blade, at the compressor side, or the turbine engine part, and where we use superalloys, or these kind of red marked areas, nose cone, leading edges of the wings or the fins and so on. And this is where we actually can make a lot of difference in terms of new material development, also coatings. Manoj is a PhD student. He works on this kind of thermal barrier coatings. Now, what actually is novel here is that normally you have these kind of a bond coats, and these are essential because otherwise the top oxide will not bond with the underlying metallic substrate. But he showed that alloying with gadolinium, he is also able to reduce the conductivity. You need a thermal barrier so that heat doesn't flow. So he is able to reduce the conductivity of the coating, of the normal zirconia coating, by way of alloying with gadolinium oxide. Now, this entire clue comes from a very old work, and I take really pride in saying that way back Jyotsna did, while doing her PhD, showed that you actually can develop in situ silicides on the matrix, and she could create a hyper-eutectic microstructure in a with a composition which is hypoeutectic. I hope you understand that if you have the eutectic, we are talking about less than eutectic hypo, higher than eutectic hyper. So to create hyper-eutectic microstructure with hypoeutectic composition was made possible because of the non-equilibrium processing condition by laser. So by doing that, it was possible to create almost a 90% silicide layer on top of the surface of a component with very easy binder of titanium alloy. And the advantage is that if you have a silicide layer which is monolithic on the top, it's very brittle. So it's in all probability during thermal cycling, it will crack and spall off. But when you have tiny little silicides dispersed throughout the matrix, and now you're actually making life of oxygen difficult. Oxygen has to get inside and titanium has to flow out. They meet each other, form oxide, and that's the danger you want to prevent. Now, you make life of oxygen difficult because oxygen cannot penetrate like this. Titanium cannot go up like that because you have layers of barriers uniformly distributed. So I still believe that the whole world believes that always the surface protection against temperature lies in oxide, I believe that we haven't explored the intermetallic route very well. In fact, these are other examples where we also have done a similar work on superalloy. The last thing that I want to mention to you is that this is one of my moment of pride. I should retire in about a few years from now. 1995, I got first exposed to laser as a tool for material processing in Professor Steen's laboratory in Liverpool. So since then, 1992, I had the first brush. In fact, that's also a matter of pride. You know, one of the first ever laser-based material processing thesis, not at PhD, not at master's, at undergraduate level, was that of Sundar Pichai. So Sundar worked with D.N. Bose and I and tried to anneal semiconductors by laser annealing. So all these years, since early 90s until 2018, I always carried a dream that someday I'll have a laser lab of my own. Since I never had a laser lab of my own, I have worked with any laser laboratory you name in the country and possibly abroad. I have worked or collaborated with. So I want you to also seriously think of that example, that why not reach out to, I may not have all the facilities that I need. In fact, when I was here, I remember some groups came and said, sir, we must have an XPS, otherwise we can't proceed. I said, how many labs in the country have XPS? Eventually, we of course installed XPS. I don't know whether it's working or not. But the same thing in 2018 when finally I got, so just look at the timeline, October 2019, the machine was finally installed. 3 months ahead of pandemic. Machine was installed, March, everything was closed down. Still, I managed to run the lab and not sitting in Kharagpur, I transferred to Ranchi by then. So that's one of my very big satisfaction, that I have a very active group working in IIT Kharagpur using this machine, and which is already now more than 5 years old and is producing very good amount of results. Not extraordinary, not comparable to the best in the world, but certainly is a very active laboratory. But I'll end saying just showing you two more important slides. Look at this very carefully. What is plotted here is the Human Development Index based on health parameters, education parameters, and living standard parameters, all as per the UNO's definition. Human Development Index as a function of per capita power consumption. I told you there is no growth, there is no development without energy. So how much energy you consume to improve quality of your life. If you plot that, the universal or the global curve follows a path like this. So this is the equation. This is where Norway, USA, Germany, South Korea, they lie. They are above the world average or the trend predicted from the world average. India is about 50% of that. The good thing is that India is not off the curve. So if we want to be Viksit Bharat by 2047, we have a job at hand, and we must acknowledge that. Otherwise, it remains a hollow slogan. And that can be realized not necessarily by politicians. We better be aware that this job of taking India from 0.5 to 0.8 or 0.9 on this curve will not be done by the politicians. Will have to be done by the members of the enlightened class. We. What can I do? Where can I contribute? Is what we must think very seriously. I'm not going to solve the problem if I'm a class scientist working in CGCRI. I don't think I can make a huge difference to the issues of an agricultural scientist or a medical technologist or something like that. But I certainly can think of quality of glass in certain applications so good that it's comparable with the rest of the world, or I may even come up with a new technology of glass. I mean, we have the finest, one of the finest fiber optic drawing lathe here. what new component can I make out of that, which will be 10% better than the best in the world. So this is the population scale chart. Here, China and India is nearly the same. So for nearly 40% of the world's population live in these two close neighbors. But economic parameters wise, 30 years ago, China was in a way possibly even inferior than India, 25 years ago. In last 25 years, they have made phenomenal progress. If that was possible in China, why not here? But of course, we have to be very pragmatic. Now, this is the GDP growth per capita in US dollar terms. By the time we reach 2047, we are talking about more than $25,000 per capita per annum. It's a respectable number, even by inflation, taking into account inflation. But what causes concern are these two bottom graphs. If US spends $343.4 lakh per person, per researcher, per annum, India spends less than half. And India's outlay in research in terms of percentage GDP is still very, very poor at 0.65% compared to easily 2, 3, 4, even 5%. So unless these interventions happen, you and I as an individual cannot make a huge difference. While that is true, it is also equally true that whatever is made available to me, am I making enough utilization of that? Am I clear in my conscience? So I would end saying that science is pursuing the truth relentlessly, regardless of its necessity or immediate application. Science is universal. Engineering is for providing solution borrowing from science. Technology is the last mile for societal benefit based on scientific discovery and engineering inventions and innovations. And if India has one unique resource and strength that the entire world envies, that certainly is our demographic dividend. So if you talk of demographic dividend, then you have to educate, you have to provide equal opportunity, you have to enable, and then charge them with certain responsibility. So I have some other thoughts and that can wait. So I'll just stop here telling you that, when Naresh called me, it was very difficult to say no to that because after all CGCRI. But then I was very hard pressed for certain travel commitments. And then I asked him that, what do I talk about? He said, up to you. Made my life even more difficult. Had he said that you talk of the A, B, C, would have been easier. Then I thought that this is one thing which I've been saying off late in various LEADS program, many of LEAPS program and LEADS program. You probably know leadership program. I think at this stage of my career, it is my sacred duty to share some of the experiences that I have gained over years of working in various places like CGCRI or IIT Kanpur or IIT Mesra and IIT Kharagpur for sure, and also being associated with two of the major peer groups in the country in engineering, INAE, and in science, Indian National Science Academy. There's a lot of talent available. There's a lot of willingness that exists, but somehow we are not able to get the synergy. That's why I thought I should talk about synergy in science, engineering, and technology for Viksit Bharat at 2047. Thank you very much. Jai Hind.
Thank you, sir, for that insightful presentation. We are truly grateful for sharing your valuable insights on the importance of science, engineering, and technology for the Viksit Atmanirbhar Bharat. Now, I request our director, sir, to kindly present our chief guest, Professor Indranil Manna, with a memento, flower vase, and grace with a shawl. I'd like to mention that the flower vase has been made by our beneficiaries of CSIR-CGCRI. Hand painted. Now I request our director sir to felicitate our chief guest with a memento. Moving forward, now I request our director sir and our chief guest to release the Technology Compendium 2024. The Technology Compendium showcases the technological advancement achieved by CSIR-CGCRI on various forums for the last 1 year. With this, we come to an end. Therefore, I request Mr. Siddharth De, Controller of Administration, CSIR-CGCRI, to present a vote of thanks.
Respected gentlemen on the dais, our chief guest for the day, Professor Manna, our beloved director, Dr. Murmu, and chairman of the organizing committee, Mr. Sitendu Mandal, distinguished guests, my dear colleagues, ladies and gentlemen. It is an honor for me to be proposing a vote of thanks at the culmination of this eventful program today, our birthday of CGCRI. We have been celebrating since morning. But first of all, I'd like to propose a vote of thanks to our chief guest for the day, Professor Manna, for making time out of his very busy schedule. We understand how pressed he is for time, and in spite of his business, he has made it possible to be here and presented this Atmaram Memorial Lecture, which was actually wonderful. As a kid, we all used to hear this old phrase like India is a developing country, and we used to wonder at what time India will become a developed nation. So now that this target has been set to somewhere 2047, we still wonder whether we will be able to achieve it. And today, Professor Manna has so nicely demonstrated and presented India's position, juxtaposing the other nations of the world, the developed nations of the world, and where we stand today. And we do believe that we will be able to traverse the right path and achieve our target by the year 2047. Thank you, sir, for your wonderful address. My thanks to our beloved director, Dr. Naresh Chandra Murmu. He has been managing 2 big laboratories of CSIR, which is a very difficult task. And in spite of that, he has inspired us and has always been behind us. And we owe him for making this program a success. Thank you, sir. Dr. Sitendhu Mandal, I did not say very much about him because I've always told him in the past also that he is like a dose of energy. His vocal tonic is such that if people, even when we are reluctant to do something, start doing it. So thank you, sir, for being with us and for everything. And you know, for a program of this magnitude to take place, it does require a lot of people. But there is a group of people in particular I'd like to thank who had made today's event very colorful. That is our cultural program team, Mr. Sukamal Mandal, Dr. Somnath Bandyopadhyay, and the others who have presented us with a beautiful afternoon. It was wonderful listening to your music. Thank you so much, sir. I also take this opportunity to congratulate the winners of various awards. And finally, all those people who have worked behind the scene to make today's program a success, the various committee members, and all of you who are still present at around 6:20 in the evening to listen to everything. Thank you all. Thank you very much.
Hello? Yeah. You know, I'll be failing in my duty, Siddhartha, with your permission and your permission, if I don't acknowledge all those who are responsible to teach me about glass and ceramics and also the technology part. One of them is Dr. Bhadra, he's sitting here. When I mentioned in the morning, Dr. Maiti, Devuda, Devabrata Basu, Kamal Das Gupta, I may not be able to recall all of them. When I joined here, I was not even 50. So obviously I learned enormously from them, and I just would like to repeat that this laboratory, though this is something which I didn't endorse then and not even now, that half the population come from 2 hours of travel or 3 hours of travel and so on. If we could all live in the same campus and work together, we would have done phenomenal work. But I thought I would just make a mention, both on behalf of my wife and I, we hold CGCRI very close to our heart, and we carry enormous amount of fond memory, which have taught me a large amount, enormously and substantially towards my journey in professional life. Thank you very much.
Thank you, sir.
Now I request everyone to stand up for national anthem.
जनगण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उत्कल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय जय हे।
Thank you one and all. I request all the HODs to come on the dais for a group photo.